Is Muhammad Firdaus bin Abu Bakar, matrix number Beee2354 from BET section 2/1. For introduction of this project, based on the project that was given, we are needed to produce or simulate a circuit that is given based on the block diagram. Based on the block diagram given, we need to produce 6 circuits, which is 2 oscillators, summing amplifier circuit, rectifier circuit, and voltage regulator circuit. Wein bridge oscillator is a type of electronic oscillator that generates sine waves. It can generate a large range of frequency. A diode bridge is an arrangement of 4 or more diodes in a bridge circuit configuration which provides the same output polarity for either input polarity. The summing amplifier is another type of operational amplifier circuit configuration that is used to combine the voltage present on 2 or more inputs into a single output voltage. Active filters contains active components such as operational amplifiers, transistors, or FETs within their circuit design. A voltage regulator is a circuit that creates and maintains a fixed output voltage irrespective of changes to the input voltage or load conditions. Voltage regulators keeps the voltage from a power supply within a range that is compatible with the other electrical components.
My name is Pasha Gonzalez. My matric number is B08201021. Today I want to present assignment, which is electronic assignment about oscillator. The introduction of oscillator. An oscillator is the electronic circuit that produces a repetitive oscillating electronic signal, often a sine wave and a square wave. Oscillator convert a direct current, which means DC, from the power supply to the alternating current signal. They are widely used in many electronic devices. Common example of the generated by oscillator include signal broadcast by radio and television transmitter. That's an introduction of oscillator. Now we go to the task. In the task we have given the guideline, which means the oscillator we have to use the oscillator Wein bridge oscillator and produce the output of 1 kHz, and DC supply for the OM amplifier is 15 volt. Alright, before we construct the circuit, we have to do a calculation. In the calculation, we assume in calculation for oscillator 1, we have to assume the resistor 1.5. We assume the resistor 1.5 kilo ohm, and then put the resistor in the frequency equation, and then we will get 106 nanofarad, which means we assume it as 0.1 microfarad, and then we want to check is it we get the 1 kHz. We substitute the value of the capacitor to the equation. Before that, before we substitute the first equation, we put the frequency by 1 kHz. After that, we substitute the value of capacitor to get the 1 kHz frequency, and then we put the 1.5 kilo ohm for the resistor and 106 nanofarad for the capacitor, and then we will get 1 kHz. Alright, after we get the value of the capacitor, resistor, and then we construct the circuit. This is the circuit that we construct. which means we have to put the VCC for the positive OM amplifier and negative 15 for the negative OM amplifier for the input of DC. And then we put the resistor R6 and R8 1 kilo ohm. C capacitor for C3 and C4 is 0.1 microfarad. To get the feedback resistor, we have to times by 2. The RA must times by 2, which means the RA now is R7 times by 2 is 4, and then we assume that as 4.3 because just in case the signal won't come out. Alright, and now we run the simulation. We will get the signal channel 1, the yellow one, channel 1 is 1.04 kilohertz, and the output of the signal is 13 volt. Alright, now we go to the second oscillator, is the oscillator 2. In oscillator 2, same step in oscillator 1, we have to assume the resistor, but in the oscillator 2, the guideline tell to make the output is 20 kilohertz for the oscillator 2, but the oscillator 1 is 1 kilohertz, different between the frequency. Right. For the oscillator 2, we assume the resistor is 2 kilo ohm, and then we put on the frequency, equation frequency. We set the capacitor, and then we put the frequency by 20 kilohertz, and the resistor is 2 kilo ohm, and then we will get 3.979 nanofarad. Alright, and then we want to check whether we get the 20 kilohertz or not. We swipe the capacitor and the resistor in the same equation of the frequency 1 over 2 pi RC. R is 2K and C is 3.979 nanofarad, and then we will get 19.999 kilohertz. We assume it as 20 kilohertz. Alright, after we get the calculation and we get the value of the resistor and capacitor, we construct the circuit. Okay, this is the circuit that we construct. This is the circuit we construct. Alright, we same as oscillator 1, we put the positive 15 and negative 15 for the input of DC or M amplifier, and then we key in the value of the resistor for the R1 and R3 is 2 kilo ohm, and capacitor C1 and C2 is 3.4 nanofarad. Alright, and then how to get the feedback resistor feedback is we times by 2 the R2, which means 10 R2 time by 2, which means 10 kilo ohm times 2, we get 20, and we add 0.5 because any issue to avoid the issue of the signal won't come out. And then we run the circuit, we will get the frequency of the oscillator 2 is 19.3 kilohertz, and the output is 5.14 volt. Alright, after that we have to do the summing for the oscillator 1 and oscillator 2. Summing for the oscillator 1 and oscillator 2. Okay, in the equation, how to do the summing? The RF must equal to R1, R2, 1 kilo ohm, and then V in 14.4, and V in 1 is 14.4, and V in 2 is 14.2 milli. And then we do the calculation to get the V out. The RF divided by R1, and then times by V1, V in 1, and RF divided by 2 times by V in 2, and then we get the V out, key in all the resistor value and the input value, and then we get the 14.1 volt. Alright, and then we get the 14.1 volt. So we construct the circuit. This is the circuit for the summing. Right, this is the for the resistor for the R1. So resistor for the oscillator 1, and this is the resistor for the oscillator 2. And then we will get the value of the. Okay, this is the value of the output. After summing in each oscillator 1, oscillator 2, we get 14.1. Alright, this is the three signal which we combining by oscillator 1, oscillator 2, and oscillator 3. We will get this kind of frequency sine wave. This is kind of sine wave. This kind of sine wave. Because channel 1 is oscillator 1, we get 1.04 kHz, and output is 13.0, and oscillator 2 is channel 2, we get a 19.3 kHz, and the output is 5.15 volt, and then the summing output we get 14.1. Right, that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Izzati binti Muhammad Assignment, and I will explain about active low pass filter. Active low pass filter, the attenuation of the signal, the amplitude of the output signals is lesser than amplitude of the input signal in the passive circuit. In order to overcome this disadvantage of passive filter, active filter is designed. A passive low-pass filter connected to either inverting or non-inverting OM gives us a simple active low-pass filter. First order active filter is formed by a single OM with RC circuit. A simple RC passive filter connected to the non-inverting terminal of an operational amplifier is shown below. This RC circuit will provide a low frequency path to the input of the amplifier. The amplifier acts as a buffer circuit providing unity gain output. This circuit has more input impedance value. Even though the input impedance of the OM height below the cut-off frequency, this input impedance is limited by the series impedance, which is equal to R plus 1 over J omega C. The output impedance of the OM, which is connected in the circuit, is always low. This circuit will provide high stability to the filter. The main drawback of this configuration is voltage gain is unity. Even for this circuit also, the output power is high since the input impedance is low. Second order low pass filter. just by adding an additional RC circuit to the first order low pass filter, the circuit behaves as a second order filter. The second order filter is shown below. This is a circuit that I will construct in my multi-sim. The gain of the above circuit is A max equal to 1 plus R2 over R1, and the cut-off frequency of second order low pass filter is RC equal 1 over 2 pi square root C1 multiple C2 multiple RT multiple R4. The frequency response and the designing step of the second order filter and the filter and first order filter are almost same except the role of the stop band. The role of value of the second order filter is down to the that of first order filter, that is 40 dB over decade or 12 dB over octave. This filter stop the high frequency signal. Okay, this is my multi-sim and this is my water. I will show my multi-sim. This is my multi-sim. As you can see, R1 and R2 is 1 kilo ohm, RT 1 kilo ohm, R4 is 1.0706 kilo ohm, C1 and C2 19.89 nanofarad, and DCC is 15 volt, VDD is negative 15 volt, and I use AC voltage 1 VRMS and 1 Hz. Okay, and this is my output. This is my output. I got 8.11 kilohertz and 5.915 dB. Okay, that's all for me. Thank you.
Assalamualaikum to Madam Ida Shafiza. I am Nur Afifah binti Abu Talib and my metric number is B0820458. In this project, I will present on my part, which is full bridge rectifier. Okay, as we know, the rectifier circuit is to convert from alternating current, AC current, into a direct current. Okay, so in this project, I was instructed to use a capacitor that has 1 microfarad. Okay, so when using a rectifier circuit, the result will get a ripple in the waveform. To smooth this, we simply add an electrolytic capacitor or capacitive filter in parallel to the load. The capacitor charge during the increase in voltage and stores the electron. It then releases them during the decrease and reduce the ripple. Okay, so this is the manual calculation. BDC is equal to 2 Vp over pi, and we get 19.09. Vp out is equal to Vp in minus 1.4, and we get 28.6, and the V ripple is 1 over 2 Fc, and we get 500 volt. Okay, so this is simple explanation for calculation. Next, okay, this is the full bridge rectifier circuit, which has 200 ohm of load and 30 VPK of source and 1 kilohertz of frequency, and the last one is capacitor 1 microfarad. Okay, let's run the simulation. Okay, the measurement that we get, the result that we get for Vp in is equal to 30 volt, and for V out is equal to 28.2 volt. So this is quite same with manual calculation that we get is 28.6 volt. Okay, that's all from my part. Thank you, Madam. Assalamualaikum.
Okay, hi and Assalamualaikum. My name is Bashira binti Baharudin. My thermometric AB0820104440. So now for my part, I want to explain about voltage regulator and load. So from the question given, the question are required, the output voltage is 5 volt. Voltage regulator type, we are using operational amplifier shunt regulator circuit, and then for the value of load power is 1 watt. Okay, before we start, we need to know what is operational amplifier shunt regulator circuit. So the shunt regulator or shunt voltage regulator is a form of voltage regulator where the regulating element shunt the current to the ground. The shunt regulator operates by maintaining a constant voltage across its terminal, and it takes up the surplus current to maintain the voltage across the load. Okay, for the load regulation, refer to the ability to maintain a constant voltage output from a power supply despite change or variability in the input load. So, the smaller load regulation is the best for power supply. And then, a well-regulated power supply can have a load regulation of less than 1%. Okay, now this is operational amplifier shunt regulator circuit that we are using. For the calculation, we are assume that R2 and R3 are 2 ohm. So for the formula of voltage output is zero voltage multiplied by R2 and R3 parallel, and then we can get 5 volt. For the power output, we assume that R4, which is RL, is 25 ohm. So the formula is voltage, the power of 2 divided by RL, which is R4, and then we can get 1 watt. Okay, now this is a basic operation of a shunt voltage regulator circuit that we are using. So for the input voltage, we are using 7.55 volt. And then for the R1 and RS, which is R5, we are using 1 ohm. And then for the sinusoid, we are using 5 volt. For the operational amplifier, we are using 741. And then for the BJT, we are using BC107BP. And then for the R2 and R3, we are using 2 ohm. And for the lastly, R4, which is RL, we are using 25 ohm. Essentially, the load is operated with a resistor in series with the voltage source and the shunt regulator in parallel with the load. So after we run, we can get the output. For the R load, which is voltage output, we get 5 volt, and for the power output, we get 1.008 watt. So, so for the result output voltage and power load are the same as required from the question, which is we get power output is 1 watt, and for the voltage output is 5 volt. Okay, that's all for my explanation about voltage regulator and load. Thank you.
For the discussion, from this assignment, we can discuss that oscillators produce electrical signals from DC signal to AC signal by summing the voltage amplifier to combine the output signal from the oscillator. An oscillator is a circuit or device which produces a continuous repeated alternating waveform without any input. After that, we use active low-pass filter to alter the frequency response to produce more selective output response by making the bandwidth of the filter even wider. Active low-pass filter is a transition from low-pass to high-pass filter. A rectifier is a device that converts an oscillating two-directional alternating current into a single directional direct current. Besides that, voltage rectifier is used to convert the AC signal to DC signal to require operated system. Lastly, the output signal that is formed from the rectifier goes to the basic shunt voltage regulator to provide regulation by shunting current away from the load to regulate the output voltage. As for the conclusion, we can conclude that from the project given, based on the block diagram, we need to create and design 6 circuits that consists by using 2 oscillators that can produce a continuous waveform without any input. Active low-pass filter is used in this project to alter the frequency response by making more selective output response by making low-pass filter to high-pass filter. Besides that, rectifier is used to convert an oscillating 2-directional alternating current into a single directional direct current after low-pass filter is settled. Voltage regulators is used in this project to supply the power for output voltage, and by using oscilloscope, we can get the value of measurement reading for frequency on each circuit and compare the result value with the calculation that we have calculated. Lastly, we use multi-sim software for this project to identify and solve the problem occurred and complete the project. Thank you.